So, inscribed angles. I kind of gave you a little sneak preview on Friday about this. Do you remember that? You don't? Well, why not? I thought that's all you think about is geometry over the weekend. Is that not true? Well, that's hard to believe. All right, let's change that. All right, now we can do this. So let's make a circle, obviously, because the whole chapter is about circles. So, there we go. So I kind of talked about this on Friday, but, I wouldn't expect you to remember. All right, there's a circle. What's that dot in the middle? What do we call that thing? The center. The center. Just the center. Just the center of the circle. Okay, here's a little review. We learned something about this angle and the arc that it cuts off. Do you remember that? What do we call this angle, by the way?
The central angle.
Central angle. Very good. Okay, so let's say that's 70 degrees. All right. So we talked about this before this chapter. Right, we said that if the central angle is 70 degrees, then it cuts off a what? What does it cut off? What's that thing right there from there to there?
Arc.
It's an arc, right? Cuts off an arc, right? And what's true about the arc in relationship to the angle, the inscribed angle? What is it?
The length.
It's the length of it?
The length of the arc is
It's not length. Length is like if you measured it, if you put a string around it and you tied it and you made it tight and you actually took a ruler and you measured it. So if you said the length of it, that would be like in centimeters or inches or feet or something like that, okay? Right now, we don't know anything about that. But we do know something else. We know the measure of the angle. When I say the measure of the angle, what does that mean? Does that mean it's 5 inches? No. What does it mean? It means it's a certain number of what? What do we measure it in? What do we measure the measure of an angle? No? Come on, you guys. It hasn't been that long.
Degrees.
Yes, in degrees, okay? So if this is 70 degrees, what's this arc right here?
70.
It's 70 degrees, all right? So the intercepted arc is equal to the inscribed angle.
So that
Remember that?
The other half.
Yeah.
210. No,
Is it?
no, it's 290.
No, yeah.
Yes, 290. Very good. All right, so yeah, that would be, because the whole thing is what? Whole way around it, 360, right? And that's how you got the 290, with 360 minus 70. All right? Everybody good with that? I don't know. You're scaring me because I didn't get much response on this. You did say it?
You did.
Okay. I didn't hear you. So now let's do this. Let's keep the center there, but I am not going to do the inscribed angle. I'm sorry, I keep saying inscribed. I haven't even talked about it yet. I'm not going to do the central angle. What I'm going to do is this. Actually, we don't even need the center there for this. I'm going to draw a chord there and a chord here. So we've got an angle, but is this the central angle?
No.
Why isn't it the central angle?
It's not in the center.
Because, right, the vertex of it's not at the center, okay? But it is what? On the circle. Now, we don't call it an on anything, but we call this, do you remember what it was? It's the title of the lesson. Good. It's an inscribed angle, all right? Everybody got it? So what does an inscribed angle do? Well, where's the vertex? The vertex lies where? Where does it lie? Come on, somebody tell me. Somebody help me out. You're scaring me. Where is it? Where's the vertex? Where is it? In relationship to the circle, where is it?
On the dot.
It's on the circle. It's on the circle. The vertex is the dot. Okay, it's the point where they intersect. All right? The vertex is on the circle itself. A lot of people think this is on the circle. Is that on the circle? It's in the circle. That's right. Where is this? Outside the circle, or the what? Starts with an E. This would be the interior of the circle. This would be the exterior of the circle. Okay. Guys got to wake up a little bit. Had a big lunch maybe. Maybe you're falling asleep. I don't know. Okay. Now, let's talk about this angle right here. Shh. We mentioned this on Friday. All right? Maybe. Shh. It's hard to have class when students are talking when I'm trying to teach. So watch. This angle is called the inscribed angle because the vertex lies on the circle itself. So if I made an angle, I'll tell you what, let's just do this. What if that angle, come on, if I could grab the stupid thing, there we go. What about that angle right there? Is that an inscribed angle?
No.
No. Is it a central angle? No, it's just some random angle inside of a circle, okay? But this is a specific type of angle, and it's called a what? An inscribed angle. Why? Because the vertex is on the circle. Everybody got that?
Yeah.
When the vertex is on the circle, then it's an inscribed angle. Now, it does something unique. Let's put some letters in here. Let's call this A, B, C. So there's something special about that inscribed angle compared to the arc that it cuts off. You hear the words that I just said? Okay, sometimes I just sound like wah, 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 wah. Charlie Brown teacher. You ever hear Charlie Brown teacher? Yeah. Sometimes I think that's what you hear me as. All right. You just hear noises coming out of my mouth. You don't know what I'm saying. Listen to what I'm saying. Okay, in relationship to this arc, there's something that's special about this angle right there. And this angle, is it equal to this arc?
No, it's something. No.
No.
It adds to something.
Nope. Anybody take notes on the last thing we did on Friday? I mean, it technically wasn't notes because I said this is a sneak preview. Nobody remembers?
Yeah, I remember.
Okay. What if I said this? What if I said this arc AC was 100 degrees? What's double? The angle is double the arc?
Double the angle.
Very good. Okay, the arc is double the inscribed angle. So if I told you that arc AC was 100 degrees, then what would angle B be? Be 50 degrees. As simple as that. Obviously, if we went the other way and they didn't tell you the arc, but they told you the inscribed angle, then what would arc AC be equal to? Yeah, it'd be double the angle, so it's 100. So the arc is double the angle. Or you could say the angle is what of the arc? It's half. Very good. Okay? Remember, if I did this on Friday, from there to there, and there to there, what's this central angle equal to? Right, that would be 100. Why? Because it's a central angle. Remember, the central angle is equal to the arc that it cuts off. But if I go like this, see what's happening? The further and further away I go, that angle gets smaller and smaller, doesn't it? Well, if I just go to the circle itself, it's always going to be 50. Now watch this. Let's do a different color so we don't get it all mixed up. I could draw another inscribed angle anywhere, any point on the circle. Okay, let's go right here. And if I went to A, and then I went to B, or C, I'm sorry. If I went to C, that also makes an inscribed angle, doesn't it? So how many degrees do you think that angle is right there? We'll call it D. Yeah, that's also going to be 50 because it cuts off the same angle, doesn't it? All right, so that would be 50 as well. And we actually have a theorem that talks about that. I don't even think we've gotten to that theorem just yet. But I think we're just about there. Yeah, good enough. Everybody with me on that? Okay, so let's do an example. Everybody wants to do an example, right? Because why? Why do you want to do an example?
Helps you see the problem.
Yeah, it helps you see the problem because you know you're going to see something like that on the homework. And if you see it on the homework, where else are you going to see it? On a quiz or a test. That's right. Okay. So let me draw this thing. Give me a second. You should be drawing it too, so you shouldn't just be sitting there watching me. Oh, good. All right, so what if I go... It's basically what we just talked about. It's really not any more difficult. We're just kind of reinforcing it a little bit. That's all we're doing. And, oops, wrong thing. What did I just do right there? Let's get rid of that. Okay. Let's try this again, and let's go to here. Yep, that's what I wanted. Just making sure I'm drawing this right. And let's go to here. All right, so that's kind of crazy looking. Let's put some letters. This is V, this is W, X, Y, and Z. And they tell you some stuff. They tell you that this little angle Z is 55 degrees. They tell you this arc VW is 60 degrees. Okay, and they want you to find two things. They want you to find part A. They want you to find angle VYW. VYW. So they want you to find that, and then they want you to find arc WX. All right, so here's all the stuff they give you. They tell you all this stuff in the picture, is true, and you just have to find the other stuff. It's probably no harder than what we just did because we just talked about that. So V, it's angle VYW. Let's find VYW. There's V, there's Y, there's W. Oh my goodness, this is so easy from what we just talked about. It's 30, exactly. You see it right away, don't you? Why? Because it at Y, this angle cuts off right here, and it cuts off right here. So what's the arc in between? It's 60. What's the angle? The angle is how much of the arc? It's half of the arc. So that would be 30 degrees. So that would be 30. Very easy, correct? All right, what's the next one? Arc WX. So let's just make it a little bit thicker. So that arc right there is what we want to try to find. Let me see something. Yeah, okay. What about 110? What's the 110? Let's make this a different color. It is 50. How'd you get 50 though?
Because if you do it out the central angle, it would be 60.
Central angle?
That if you add it, if you add 55, you get the central angle for that angle, and then you minus 60.
You keep saying central angle. We don't have a central angle here. Give me the right word. Are you talking about this angle right here? Yeah, inscribed. Okay. Yep. Yep.
And then minus 60.
You got it. Okay. I just wanted to make sure you said the right words though, instead of central angle, because there's no central angle here, but you do have an inscribed angle. So look, it hits here at V, and it hits here at X. Do you see that? So let me let's change the color of it a little bit. I'm going to try not to overwrite that pink one. So I'll go along here. Oops. There we go. All right. So do you see the green one? How much is the green one?
110.
How did you know 110 that easy? Well, how did you know that was 110 so easy? That's right, the inscribed angle. Okay, so the arc is twice as much as the angle. All right, just want to make sure everybody sees where they got that 110. Okay, so if this is 55, it hits here at V and it hits here at X. So that green arc right there, arc VX, is 110 degrees. What are we trying to find? That pink one, right? So what do? From here to here is 60, right? So you take, now it's 110 minus 60, which is 50. All right, so that pink one, let's put it in pink. So that would be 50 degrees. Everybody good with that?
Yes. Yep.
Yeah. Because this angle right here, see this angle? Where does it go? It goes to here, right? And then it goes to here. So that's that green one. See that green arc? That's that whole green arc right there. So that arc is double the inscribed angle. Right? So twice 55 is 110. So the green one is 110. Then you take away just from V to W, because that we know that's 60. What's left over? This, which would be 50. There's your 110 minus 60. Everybody good? Okay. So that's the kind of stuff you're going to have to look for. All right? Look for inscribed angles. And again, you know the arc is double the angle. Got it? Or the angle is what? Half of the arc. So if you can remember that, you'll be good. Let's put that answer right there. It's 50 degrees. Okay, let's talk about a couple other things. Again, these are kind of common sense. The second theorem, I think, is really interesting. I kind of enjoy the second theorem. I know you probably think I'm weird for enjoying theorems in geometry, but I kind of like the second one. This first one, like I said, is basically just common sense.
This did. Alright. This did.
All right, here we go.
This did. Let's start this. Ooh,
Stop
Come on. I'll just move it like this. All right, guys, knock it off. It's not really that funny. No, let's not do that. Let's do this. All right, sorry. Let's move it right there. Okay. And now what I'm going to do is I'm going to take that angle and, yeah, let's do like this. All right, here we go. Now what I did is I copied and pasted. So somebody tell me about this angle and this angle right here. Yeah, they're equal. So if I told you, I'll just do this with numbers. We'll read the theorem in a second, but it should make sense to you. Okay, you should look at it and like, oh yeah, of course, that makes sense. So watch. If that's 30 and that's 30, what must be true about this arc and this arc right here? They got to be equal to each other, okay? So if I have equal, let me read the theorem, okay? It says incongruent triangles. So I made these because, listen, I made these congruent because I copied and pasted, okay? So they are congruent circles. It says inscribed angles are congruent, okay? So these two angles would be congruent if they intercept, or it says if they intercept congruent arcs. So let's do this. Instead of putting numbers in here, let's get rid of the numbers. We'll eventually do that because you know you're going to put angles in here, don't you?
Yeah.
All right. But what if, let's call this ABC. ABC, call it DEF. Okay? What if they did this? What if they put a little tick mark here, a little tick mark here? What does that mean? What does that mean? Arc BC is what? Congruent to just arc EF. That's right. Just arc EF, okay? So from here to here is equal to from here to here. Everybody got it? That's the only information you knew. Well, you know they're congruent circles, okay? They do tell you that the circles are congruent, so they have to tell you that. So if this arc and this arc are equal to each other and they're congruent circles, what does that mean about angle A and angle D? Yeah, then they're equal to each other. So basically it says this. If arc BC, remember, incongruent circles. So you have to know that the circles are congruent. I'll just write into there. So incongruent circles, if arc BC is equal or congruent to arc EF, then, put a comma, then what must be true? If the two arcs are equal, then what?
Inscribed?
Right, the two inscribed angles are equal. So what angle, we'll just call it angle A, is that all right? Angle A must equal what? Angle D, all right? And you can go the other way. This theorem actually says if and only if. We've talked about this before, not a whole lot. If and only if. There's a shortcut way instead of writing if and only if, because you see it quite a bit in geometry. Instead of writing that whole thing, a lot of people will write this, IFF. So when you see IFF, what does that mean? If and only if, okay? So it's just a shorthand way to write it. That's all it is, okay? So you don't have to write out the whole thing. So what it says is, if you have congruent triangles, if this is true, then if the arcs are equal, then the angles are equal. If and only if means I can switch the if and the then. So then what can we say? If what? If the angles are equal to each other, then the arcs are equal. Everybody with me on that? All right? That's what if and only if means. All right? So this says, incongruent circles, inscribed angles are congruent if and only if they intercept congruent arcs. So the if and only if means I could switch the arc thing and the angle thing. All right? So in one sentence, you don't have to say them both. All right? The if and only if means I could go either way. I could either say this is true, and I can also say that that's true. That's my if and only if statement. Everybody with me? And that makes sense too. Let's do the 30 thing. All right, so what if I told you that arc was 60 degrees and I told you this arc was 60 degrees? What must be true about angle A and D? They got to both be 30, right? Because they're half, which means those two angles are equal to each other. It's kind of easy to see, don't you think? Yeah, it's almost like, well, of course. It's one of those things, you know, but it is a theorem. It can be proven. There you go. Here's the cool one. Here's the theorem that I like. I think this is kind of interesting. You may or may not think it's interesting, but that's okay. Oops, what did I do? I don't know. I think I grouped them together and I forgot to ungroup it. That's probably what I did. Let's just do this. Now this time I'm going to want a center. What I'm going to do is I'm going to draw a diameter. All right, I can draw it diagonally like this, up and down. I'm just going to draw it basically straight across, horizontal. Okay. Now watch this. I think this is pretty interesting. I'm going to do this in a few different colors. I could take any point on this circle and draw an inscribed angle that cuts off a semicircle. What's a semicircle?
180.
Yeah, half a circle, or the arc would be 180 degrees. Exactly right. So watch this. This is kind of cool. Go ahead. What were you going to say? I think you're onto it. I think that's right. That's exactly what we're trying to show here. That's good. All right. So look, if I take an inscribed angle from any point on the circle, is that particular point special? No, not at all. I could pick any point on that circle. Look what it's doing. It cuts off right here and right here. It cuts off a what? A semicircle, 180 degrees, correct? So what does this angle have to be? This has to be 90 degrees. So that's a way that you could draw a perfect 90-degree angle, right? Draw a circle, draw a diameter, and then inscribe the angle, right, to the, I don't know, I was going to say outside edges, but to the ends of the diameter, right, the end points of the diameter, and you've got a perfect 90-degree angle. All right, it's kind of cool. Does it just work with that angle? No. Or that point? No, I could pick a point like up here if I wanted to. All right, and let's go to the end of that diameter and the end of this diameter. Check it out. What does it do? It makes a what? 90-degree angle. All right, I could do that all day long. I could do it down here. I could put it anywhere. Where do you want to put it? Let's put it like right underneath of it. Just see if it works right underneath of it. And I could cut off that semicircle. So I go to one end of the diameter, then I go to the other end of the diameter, and again, guess what we have down here? We now have a right angle. I think that's kind of cool, don't you? All right, so I can make a perfect, as long as your circle is perfect, right? And your center, you know where your center is, a lot of ifs. But if I had a circle, and then I was able to draw a diameter, and then I do an inscribed angle from any point on that circle to an inscribed angle, that angle will always be 90 degrees. Why? Because it's half of the arc that it cuts off. And if you're cutting off a semicircle, then what's half of a semicircle? Half at 180 is what? 90. It's 90 degrees. All right, so every one of those is a right angle. I always thought that was kind of a cool little theorem. Don't you think it's kind of cool? Yeah, kind of. I know, it's geometry. I get it. It's not as cool as rock climbing, okay, or anything. But, as far as geometry is concerned, it's kind of cool, right? Yeah. I don't know. Depends on your definition of what cool is. All right, let's do another one. Here we go. Everybody look up here. Let's do this. What I'm going to do is I'm going to inscribe. Now remember, these are inscribed what? Inscribed angles. They're inscribed angles, okay? Why? Because the vertex is where? On the circle, okay? What I'm going to do is I'm going to draw an inscribed quadrilateral, all right? So let's do it in a different color. Go to this pink color again. So watch. There's one. So there's got to be how many sides? Oops. How many sides? Two? On a quadrilateral? Four. Okay, I'm going to just draw some random quadrilateral. But look, what's special about where the vertices are? Where the vertices located? Right where? Right on the circle. Exactly right. Everybody got that? I could go through and show you why this is true, but we're running out of time. I got like 3 minutes, okay? So I can't do that. But let's do this. A, B, C, D. Now, this is everybody listening, right?
Yep.
So it says that the opposite angles of an inscribed quadrilateral are supplementary, which means what? Angle A plus angle what? C, your opposite, equals 180. Or I could say what else? What's another way I could do this? Angle what? B plus angle D It's also equal to 180 degrees. Everybody see that? All right, so this angle and this angle are supplementary. This one up here and this one down here is supplementary, which means they add up to 180. I doubt I'll have time to do this whole entire problem. I know I won't have time, but this will be part of your homework, all right? Nah. This will be part of your homework assignment. I'll set it up for you. We'll talk about it, and then you can finish it up. This is an example. It's in the book. It's example 2 if you want to write that down. It's example 2 in the book. And again, you can look at it to see if you get it right by checking the book out. All right, here we go. And they throw some diagonals in here. Right, from there to there, and from there to there. Everybody with me? You know what I meant to do? That's the center. We'll pretend this is the center. I'm off a little bit, but anyway, that's supposed to go through the center. My bad on that one. All right, so they tell you some stuff. Let's put some letters, A, B, C, D. They put point P in the middle, and they say, you want to find a bunch of things. Again, I'm just going to set it up. So they tell you this. This is the only thing they tell you. They tell you that arc DAB is 208 degrees. Where's DAB? There's D, there's A, there's B. So from here all the way around to here is 208 degrees. Everybody got it?
Yeah.
Right? From there to there. That's 208. That's the only thing they tell you. So here's what they ask you. Hang on just a second. Here's what they ask you. They ask you to find angle ABC. They ask you to find angle BDC, BDC, and they ask you to find angle DAB. Angle DAB. So there you go. So this is example 2. It's in the book. Before you do any of your homework, I want you to try to do this, okay? And then look at the book, look at the example, and see if you get the right answers for that. Everybody with me? So your homework is 1 to 13. So you're doing section 8, what did I say this was? 4? 8, section 8-4, and you're doing 1 to 13. All right, you can go.
Hey, Tim, don't leave.
Section 8-4. And it's page 372 if you need that. See you guys. All right, have that done for tomorrow, okay?